Okay, and then we put the radioactive source here. Kita letak radioactive source. Okay. And then kat sini lead screen with sleeve. Kan, ni ada, okay. And then yang lalu ni adalah beam alpha particles. Okay. And then kat sini ada hole ya. Okay. So kita letak gold foil. Okay, when we place gold foil here. Okay, and then tengok apa yang berlaku. So ada deflections apa semua. Right. Tengok, so this is the gold atom. Ni gold foil tu dalam dia ada atoms. What atoms? Atoms gold lah. Gold atom. Boleh imagine? Okay. So this is a solid. Jadi solid dia ada ni arrange like this kan. Okay. Now what happen kalau alpha particles mendekati the thin gold foil? So alpha particle. So what do you know about alpha particle? It is a alpha particle adalah what charge? So alpha particle, it is, yes, alpha particle. Kita tahulah it is a positively charged and then it is heavy, the heaviest antara electron, yeah. And then apa lagi? Okay. So kita nampak kat situ ada yang alpha particles dia deflected back macam tu. Kenapa dia deflected back? Sebab dia adalah dia repel. So this one, the gold atom dalam nucleus tu dia ada dia positively charged and then positively charged, dia repel. Okay. Next. Jawab soalan ni. So ni soalan biasa lah. Okay, figure 11.1 shows the path of 3 alpha particles moving towards a thin gold foil. 4 gold nuclei are shown. Okay, so on figure 11.1, compute the path of the 3 alpha particles. So this is easy. So you can show any of these. Yeah. So apa ciri-ciri ni alpha? So if you want to answer this question, you kena tahulah ciri-ciri alpha particle. Dia positive, dia heavy. Senang saja, heavy and positive. Jadi then gold nuclei, kita tahu dia ada positif, dia positif, dia positif. So dia akan travels to, dia akan reflect. Okay, ni katalah ni right hand side, ini left hand side of the paper. Jadi you akan draw, you answer one of them. Macam ni lah. Sini. Oops. Ke depan. And dia reflected. Lagi middle. Okay, mungkinlah dia ada ke bawah sikit. Lagi. And straight on. So, satu straight. Okay. So, mana-mana boleh lah. Mungkin ada students yang dia buat macam ni pun boleh. So, what I'm trying to show you is dia boleh mana-mana. Okay, so sama ada ini straight pun boleh. Yang ni ke bawah pun boleh. Yang ni sebab dia ke depan. Dan ni yang, this one ni yang reflected back. Okay. Okay. Kenapa yang ni mesti reflected back? Sebab this one. Nampak? Okay. Dia kena tahulah. Yang ni dia terkena pada gold foil tu. Lepas tu dia reflected back. Sebab gold foil positif, alpha pun positif. So dia repel. Ni. Right. Yang ini dia tak kena the nucleus. So you buat dia straight tapi ada sedikit yang deflected ke bawah. Dia ke bawah sikit. Okay, to show it's heavy. Dia berat. Menunjukkan dia heavy sikit. Nampak skrin lagi tak? Okay, yang ni straight. Yang ni straight to show that the atom adalah empty space. Yang ni this one. Kita tunjuk macam tu to show that atom consists of empty space. Okay, so these are the three things yang kena tahu. Heavy, positive. On figure 11.1, complete the part. Okay, so we are done that one. So 3 marks. Okay, 1, 2, 3. So 3 marks. State the sign of the charge on the alpha particle. That is easy. So it is positive. Yeah. Okay. You tak boleh tulis positif. Kenapa? Sebab dia kata dia nak sign. So sign tu we accept this one. Kita nak simbol dia. Alright. Okay. Ataupun you boleh tulis plus. You cannot write this one lah. Sebab positive is not, kita tulisan ni kita nak simbol apa? Simbol plus. Right. The nuclide notation. Okay, next. This is another easy question. The nuclide notation for a nucleus of gold 198. Okay, so this is the nuclide notation. Okay, make sure you know what is nuclide notation. Ni adalah nuclide notation. State the numbers of electrons, neutrons and protons in a neutral atom of gold 198. So, what do we have here is an atom. And the atom is neutral. So, what should be the answer? It's... Yes. How many electrons do we have? Yeah?
Screen cikgu lag.
Yeah?
Screen cikgu lag.
Oh, cikgu face screen dah tak ada dah?
Ada tapi dia tak gerak.
Oh. Sorry. Masih lag ke? Sekejap Tengok ni. Masih lag ke? This one is the nuclide notation. So 198 ni nucleon 17. Okay, so this is a neutral atom. Jadi if it is a neutral atom, how many numbers of electrons? So 79 juga. Sebab it's neutral. Okay, and then what's the neutrons? 198. Masih lag ke? Okay dah Masih lagging? Okay, so this one, what's the answer for this? It's 119. Okay, and then berapa? Number of protons. 79 also. Okay. Right, so ini soalan yang sangat senang. So you should get full mark. Okay, 1 and 3. Okay, so that's the first. Now, tengok pula yang ni. Okay, question number 10. Okay, figure 10.1 is a simplified diagram of a digital circuit. The output of logic gate 1 controls a buzzer. Okay, so When you switch turn on the switch, okay, ataupun you press the button, you will hear a sound, buzzer. Okay, so we have logic gate apa ni? This is a NOT and this is a NOR. NOR. So we have, okay, first when you get this kind of question, you tengok teruslah. So this is a NOT. This is, okay, bentuk dia ni, the shape is shape of OR. But it has here, okay, so this is actually NOR. Okay, complete table 10.1. Okay, the truth table for the circuit. Okay, input A dekat sini. So you can write sini 0, 0, 1, 1. Input B 0, 1, 0, 1. Okay. Jadi, right. So let's do this. Okay, 0, 0, 1, 1. Okay, when you notchkan dia, 0 becomes 1, 0,
1, 1, 0, 0.
0, 0. Okay, so here kita dapat tu. Okay, yang ni kita continue lah for this one. Kita continue sebab the same lagi leak. Right, and then kita ada these two. Okay, so 1, 0. Okay, so if OR, jadi 1, 0 jadi apa? Okay, first kita tak sini lah output of
1.
X. Okay, sekejap X tu kita write here. 1, 1, 0, 0. Okay. Okay. Okay, for OR, dia OR ni dia macam ni kan, dia punya algebranya. Dia whatever dia input dekat A plus input dekat B, kita notkan dia. Betul? So meaning 1 and 0, it should be 1 and 0, it should be 1. Betul? Sebab OR. But dia ada bar dekat sini, maksudnya dia akan jadi opposite. So kita akan dapat 0 here. Next, 1 and 1 or gives us 1. Tapi sebab kita ada not kan dia kat sini, ada not, dia jadi NOR. So it will be, this one will be 0. Okay, next, 0, 0. So 0, 0 should be 0. But this is NOR, bukan OR. Okay, kita bar kan, kita opposite kan dia. Jadi 0, 0. Jadi sepatutnya 0 tapi kita jadi 1. And then finally 0, 1, 0, 1 gives us 1. Tapi this is OR. Kita terbalikkan dia, oppositekan dia. So this one will be 0. Okay, so what's the answer? So the answer is 0, 0, 1, 0. So that's very easy. Okay. So 3 marks, 3 marks for that. Okay, B. Input A is the output of humidity sensor. So when you read this one, you tengok input A. So this one. So this one is about humidity. Okay. It's not wrong to write here, tapi you write nicely lah. Okay. And then dia kata, which gives logic 1 when humidity is high. So 1 means high, humidity high. And logic 0 when humidity is low. Then it says here, input B, okay, this is B, is the output of light sensor. Okay, which gives logic 1 in bright light. Okay, 1 kalau terang, 0 kalau malam, dark. The buzzer sounds when the output of Y is 1. Okay, dia just bagi tahu you all lah. Okay, Buzzer berbunyi when output of Y is 1. Okay, where is output of Y? This one. Jadi dekat sini, bila dia buzzer berbunyi? Bila the output is 1. So, here we write buzzer sound. Sebab dia kata kat sini kan, buzzer sounds when output Y is 1. So, this is Y and this is number 1. Okay, state the conditions of humidity and light when the buzzer is on. So, very direct question. You follow. When you get this kind of question, you follow je one by one. Okay, apa dia kata? State the conditions of humidity. So, kita tengok dekat sini. Where is the humidity? A. So, what can you say about the humidity?
High humidity and bright light.
Yes. Okay, yang mana high humidity? Yang mana? Humidity, this one, high. Then, light, 0. So, 0 means dark. Kan? Okay. 1 and 0. This only gives sound, the buzzer sound. Okay. The output of the digital circuit alone is not able to operate the buzzer. Okay. Ring the ring. So the ring tu maksudnya you kena bulatkan jawapan. Ring the component from the list that must be connected between the output of the digital circuit and the buzzer. So what else in the circuit? Apa lagi yang perlu ada on the circuit? Okay. To operate the buzzer. Okay, what is thermistor? So nampak kat sini dia bagi adalah electronic components. So you need to know the function of each component. Okay. So what is thermistor? Thermistor is sensor for the heat. Okay, kita tulis kat sini lah. Ni heat sensor. What about resistor? Resistor is just resistance. Okay, relay. Okay, relay is an automatic switch. Then kita ada heater. Heater is heater. And fuse, dia to limit excess current. So kat sini question dia wants, okay, to operate the buzzer. What do we need? Okay, so the answer is relay. Okay, why?
Thermistor.
Is it thermistor? Okay, thermistor is already, okay, heat sensor is already here. Dia tak perlu pun. Okay, because heat sensor is to sense heat. Okay, tapi kita, this one buzzer dia tak berbunyi waktu panas. Humid is not the same as, selalu student memang tersilap lah. Humid is not the same as heat. Humid ni adalah macam water droplet. Kan? Light, cahaya. Okay, so we don't need. Okay, so jawapan dia ialah relay. Right? So kenapa dia kata, why do you need relay? What is relay? So relay, dia macam automatic switch. Okay, so for relay, sorry, low voltage output. ataupun in simpler sentence, you can say, if we have small current in relay coil, and then we have larger. This one, I just want to emphasize, you don't need to write it in capital letters, tapi I want to emphasize that small current of relay will gives us very large current, voltage. It depends lah. If you write voltage here, ini pun you write voltage. Tapi kalau here you write, here you write current, so bawah ni pun you write current. So that partner dia lah. Janganlah you tulis satu voltage, satu current. Okay, kalau you write voltage, you write about the voltage. But okay, so this one voltage of the relay. So siapa yang large ni? Large voltage of by relay. Yang ni okay, low voltage output current in no gate ataupun gate 1. Okay, ni question. So kita tengok soalan yang seterusnya. Ada soalan tak tentang ni? Okay, so kita boleh simplify kan. Okay, this is topik dalam electronic. Okay, kita ada topik chapter 4 electric and electronic. So in this topic, okay, you kena tahu macam-macam lah. Okay, kita tahu tentang, so this is such a very big topic. Dalam tu kita tahu tentang voltage, current, and then you need to know about resistance, and then series and parallel circuit. Okay, and kita ada transformer. Magnet. Kita tahu tentang magnet sikit. Dan macam mana magnet to produce current. Alright, and then ada gate. Alright, so ni topik logic gate. So topik logic gates, you kena tahu apa? Kita ada not lagi. Kita ada and. Kita ada or.
None.
Or is these are the three basic yang kena tahulah. And then kita ada not. Okay, for and kita ada two input, one output, or two inputs, one output, or not one input, one output. And then we can combine this kan. Ini letak dekat sini or sini. Macam jadi gabung-gabungkan dia. But first of all, you must know the basic. Okay, kita tengok soalan yang seterusnya. Figure 9, question number 9. Okay, this one familiar question to everyone. Okay, boleh baca dulu. Macam ni, saya padamkan. Dia dekat sini. Okay, so that's the first question. Jadi, at the first question, you don't have to calculate anything sebab there is no current flowing. Why there is no current flowing? Sebab when the switch is at point A, kita ada incomplete circuit. Ini lalu, oops, ni incomplete. Yang ni pun sama. Okay, Ni incomplete circuit. So kita dapat 0 ampere. Okay, what about point B? Dekat point B, okay, so kalau dia dekat sini, point B, now, okay, dia connected. Okay, so current can flow. Alright, so ini the line of current flowing sini Current flows here, then here, here. So that's the flow of current. Now, what's the question wants the current. Jadi what's the formula of current? So kita ada two formula yang we can recall. So power and voltage. Tapi sekarang power ni macam tak relevant. We don't talk about power. So we can use V equals to IR maybe. Okay. Now you write formula. So V equals to IR. Do you know the voltage? Okay. The voltage given as 12 volt. Current. That is what we want. And do you know the resistance in the circuit? So sekarang ni sebabkan dia lalu point B sahaja. Jadi only this component yang works. Jadi what is the total resistance? Total resistance is only 2 ohms. Jadi kat sini 2. So what's the I? We just rearrange the formula. 12 volt divided by 2 ohm. That gives us 6. 6 apa? 6 ampere. Because it's current. Ataupun V over ohm. Okay. Next. When the switch is at point C. So kalau dekat point C, okay, dia dekat sini. Okay. So what's the current? Okay, kita tengoklah. Dia lalu mana. So what's the total resistance? Kita ada 2. Kan? 3. The current flows dekat 3. So ada 3. Resistance kita 3. And then lalu juga pada motor. So kita ada total resistance of 3 plus 2 which is 5. So they are connected in series. Nampak tak ni? In series. Dia sambung macam tu je. So first total resistance 3 ohm plus 2 ohm. So that's 5 ohms. Jadi kita tekan sahaja kalkulator macam tadi. I equals to V over R. So V 12. R kita 5. Jadi 12 divided by 5. We get about 2.4 amps. Okay. So kat sini ada 2 marks. Marks of the working and answer. So show your working. Nampak cikgu ruang dia kecil je. Tak apalah. You just write. Ni simple. Formula, masukkan, substitute, the answer. And 1 mark. No calculation needed. So you see very simple question tapi dah dapat 5 markah dekat sini. The two resistors of resistance 2 ohm and 3 ohm are now connected in parallel. Okay. Calculate the combined resistance of the resistor in this arrangement. Okay, so macam mana? Connected in parallel. Jadi when they are in parallel, okay, so that's easy. Kita ada formula 1 over R total. Sebab dia nak combine resistance only. Okay, so you just write 1 over 5. 1 over 2 plus 1 over 3. And tekan saja calculator. What do you guys get? Okay, kita dapat 3 plus 2, 5/6. Yeah. Okay. But the question wants the combined resistance. Jadi it's 6/5, but remember in physics you cannot leave answer in fraction. So you tekan calculator. Apa you dapat tu? Tak susah pun lah.
1.2.
Yeah, okay. 0.2. 1.2, is it?
1.2 ohm.
Okay, please do not leave your answer in fraction. And please remember to always write the unit. Okay, susah ke senang? Senang Okay, right. So itu ya soalan simple untuk topik 9. So ini masih lagi chapter apa tadi? Electric and Electronic. Okay, yang ni adalah part series and parallel circuit, plus you need to know about the voltage and current, and V equals to IR. So ni, these are the things that you need to know. Kena tahu kat hujung hari kan. Okay, next. So I okay, figure 8.1 shows how electromotive force of a 60 Hz alternating current supply varies with time. Calculate the time period of the AC. Okay. So ini topik apa? Masih lagi topik elektrik. So you see for this year soalan ni banyak soalan topik elektrik. Ada 3 dah soalan topik elektrik and electronic. Okay, but now it's under the subtopic EMF. Okay. Now, dia kata this is AC. AC. What is AC? Alternating. Dia alternate positive, negative. Positive, negative. Okay. Calculate the time period. So, you kena tahulah. Okay, dia bagi soalan lah. Senang pula soalan ni. Dia kata time period. So, this is the period. Okay. But now, dia nak what's the value? Okay. So, how do you get this value? Okay, you need to know one thing. Apa yang penting you kena tahu is the relationship between period and apa yang given dalam soalan. What is given in the question? Dia tak bagi EMF. So we only have this one. 60 Hz. 60 Hz is what is 60 Hz? It's a frequency. Okay, so kita tahu ada frequency dekat sini. Okay, so for this one, you kena tahu ada kaitan antara time, period simbol dia capital T. Period related to frequency this way. Okay, so you have to write that formula first. So we want the T. Kita nak tahu this T lah. So what's do you know the frequency? It's given 60 Hz. Okay, jadi 1/60 is kan calculator. So that's 0.017 second. 0.0. It's time kan? Time hertz lah. Jadi you kena tahulah hertz ni 1 hertz dia sama dengan 1 per second. Jadi kalau 1/60 per second. So that is sama dengan 1/60 second. Sebab dekat sini, ini matematik je lah, nak tengok algebra ni kat sini negatif second. Sebabkan dia per negatif second, jadi kita boleh letakkan dia dekat sebelah ni. So that's why lah kita dapat formula, akhirnya unit dia is okay, 0.017 ni. From this calculation, unit is this one. Ataupun awak tak ingat, but you know, okay, time it's in second. Okay, kena ada unit lah. Alright. Figure 8.2 shows this power supply connected in a circuit. Okay, ini ada satu circuit. State the name of component A. Alright, that's easy. A is a
Diode.
diode. Okay, B is a bulb. C is a resistor. Okay, the question tak tanya pun, tapi you kena tahu each symbol. Okay, in each time period of the AC, 1.5 times 10 to the power of 7. Sekejap ada student nak masuk lagi. Sebab ni pagi kan, ramai yang tidur ni. Tapi tak apalah, kejap. Yang ada dekat sini sekejap. Okay. Okay. In each time period of the AC, 1.5 times 10 to the power of 7 electron pass through component charge. Okay, so this one, okay, dalam topik electric, okay, dalam topik electric tadi kita dah discover apa? Okay, what have we discussed? So first tadi we talk about apa awal tadi?
VIR.
Okay, kita VIR. Okay, and then we talk about Ohm's law. Walaupun kita tak mention the word Ohm's law, tapi kita dah guna tadi Ohm's law. Okay. Okay, and then kita ada masuk apa lagi? Tentang, okay, sekarang dah EMF. Okay, and then tadi kita masuk elektronik. Sorry. Okay. Right. So now kita dah masuk tentang charge. Charge symbol dia Q. Okay, formula of charge is Q equals to IT. Okay. So what is given? So here kita ada electrons. That's true. The charge on an electron is this one. So this is number of electrons. This is the charge. Okay, calculate the average current in the circuit during one time period. Okay, 3 markah kat sini. So, you all cuba baca-baca dulu. Apa idea tak macam nak buat? So which formula it can be used here? So first one, kita tahu what's the current. Okay, ada tak current given? Tak ada. So kita boleh
Screen.
ya. Ya. Okay, tadi saya dah bagi tahu kita sekarang ni kita dah masuk bahagian charge. Dia sebenarnya soalan ni kita sepatutnya buat soalan this one first lah. Number 8, 9 dan 10. Okay, tapi tak apalah, kita buat the other way around. So kat sini this is about charge. So charge, you need to know the formula Q. Okay, what's Q? Q is the charge, I is current, and T is the time. Okay, so for this one, first of all, you have to write the formula. So what's the formula can we use? Q equals to IT. You write this first. Okay, soalan nak the current. So I equals to Q over T. So what's the Q now? Q given as 1.6 1.6 Okay, kita ada charge. Dia bukan ada 1.6 saja. Charge ni, okay, 1.6 ni adalah apa dia kata? You baca, you have to read carefully the question. This one is the charge. Charge for who? For an electron. But how many electrons do we have here now? Do we have only one electron? No. Kita ada banyak electrons. How many? This many. Jadi, so for the Q ni, you have to include all the electrons. Okay. Sebab at one time, screen sekarang ada?
Ada.
Okay, saya stop dekat mana tadi you all? Dekat sini kan? Okay, tadi dapat jawapan sama-sama lah dengan cikgu dapat 1.4. Semua ni ada tak tadi ke saya dah lost tadi?
Teacher separuh je.
Ni semua tak habis tadi?
Belum teacher, saya dengar sampai I equals to Q over T. Lepas tu kena darab dengan 1.6.
Okay, macam ni ya. So let's kita recall balik. Okay, first saya ulang balik ya. Okay, first we have Q equals to NE. So Q equals to NE, and then another one Q equals to IT. Alright. Okay, these are the things that you need to know about charge. Okay. Now N, what is N? N is the number of electrons. So what is E? E is the charge on electron. So charge on electron, ni contoh macam ni lah. So dia mesti, so charge of electron is fixed. Yeah, the value is constant, which is 1.6 times 10 to the power negative 19. Now what? Okay, next, okay, this is Q. Okay, so you need to know there is another formula for Q. What's Q? Q ni adalah charge. So another formula is Q equals to IT. Okay, so because this is charge, this is also charge. So of course they are the same thing. So kita boleh equalkan macam tu. Charge is equal to charge. Yes, it is. So and then one of these, the formula is NE, and another one, the formula is IT. So we do this, we have this equation from this knowledge. Now, when NE equals to IT, so it depends what the question wants. So now we rearrange the formula so that I as the subject, because now the question wants the current. Okay, so current equals to NE over T. Okay, NE over T, right? So that's why we have this formula here. So I equals to Q over T. So Q ni tadi equals to NE, ataupun you ambil saja formula ni. So that is what I'm doing. Alright. And then now we have this formula. So now kita just substitute the value. So what is N? So for this question, the current that flowing is not about one electron. So kita ada how many electrons here? So dekat sini dia kata the charge, this charge is only for n electron. A charge is for n electron. But how many electrons do we have? We have many. 1.5 times 10 to the power 7. So we have many electrons. So these electrons ni number lah. Inilah n tu. So we put it here. And the value of electron ni given, substitute here. And where do I get this time? 0.017. Sebab soalan nak one time period. Student kadang-kadang dia akan letak one kat sini, which is wrong. One time period. So the period tadi we have calculated earlier. Tadi kita dah jawab kat sini. So that's the time period. So kita letaklah 0.017. So tekan calculator elok-elok. So you dapat formula ni. Dapat answer ni. Tadi saya dah pergi jauh dah. So marking dia. First mark here. Writing the formula ni. Second mark. You have this one, then you substitute values. Then third marks, answer with correct unit. You mesti provide the unit. Any question? Okay, next. See. On figure 8.3, so ni 8.3. Mark with an arrow label E. You kena label the arrow E. The direction of the electron flow through component B. Okay. Now, this one macam quite difficult because now we have arrow alternating current. Symbol alternating current. Okay. Kalau it's this one, direct current macam ni, it will be very easy. Kan? Okay. So let's just do this exercise. So this is an easy question. Kalau saya ask you, if I ask you, I have this circuit and kita ada dry cell here. The taller one is the positive terminal. Shorter one is the negative terminal. Okay, so from positive to negative terminal, it's okay. What's this direction? Ni direction of apa? So that's the direction of conventional current. Now, what about the electron? Electrons travel from negative terminal to positive terminal. So now the red one is am I online? Okay, direction of electrons. Okay, so you have to know these two, yeah, the difference between these two. Okay, so that if we have a dry cell. So for this question, we don't have the dry cell. Kita ada alternating current. Jadi how do we determine? So you tengoklah what do we have here. Kita ada A. What is A? A is a diode. Soalan tadilah. Dia dah tanya you all dah. What is A? A ni is a diode. Okay. Now, what is the function of a diode? Diode, the function is a diode only allows current to flow in one direction only. Okay, so if it is in one allows current to flow in one direction only, so this is the current. Okay, so what is that current? That is the conventional current. So
Cikgu.
yeah.
So diode ni dia ada dekat alternating current je lah kan?
Selalunya we use diode dekat alternating current.
Okay, faham.
Now, kalau dia only allows current this way, maksudnya from here to here, so that is the direction of conventional current. Jadi soalan yang pertama ni, dia nak direction of conventional current or something else. So this one is about electron. So this is the direction of conventional current. Okay, so I. You don't have to draw too many because dia kata dia nak end arrow sahaja, so you don't confuse anybody, you don't confuse yourself and the examiner. So you just draw one arrow and then you must label it. Alright, and okay, another one, this one. What should be the label? Electron. Okay. Easy question, tapi you kena tahu the basic this one. Okay. Next, figure 8.4 shows a circuit with components B and C connected to a direct current DC. Okay, now we have changed something. We changed something, yeah. Now kita use direct current. Tadi we use alternating current. Okay. And it says here the EMF is 12 volts. So what does that mean? So that means here kita punya power supply is 12 volt. The current in the circuit is 0.35 ampere. So you are given current here 0.35. Calculate the power delivered by the power supply to the circuit. So you see so every time I tell you tadi kita tadi kita tengok soalan ni. Bila kita pergi je topik elektrik, so these are the things that you need to know. Okay, and then apa lagi kita tahu tadi? Power. So macam tadi pun kita nak do calculation, kita nak tahu what kind of calculation. So you need to know power equals to VI, V equals to IR, and then choose which one is relevant to the question. So soalan tadi, this is the relevant one. So kita guna V equals to IR. But now, the question asks you about power. You kena tahu dah formula of power. So what's the formula of power? Power is VI, IV samalah. Right, so do you know the voltage? It's given 12 volt tadi diberi. And do you know the current? Okay, so this is very direct question. If you look at the mark pun 2 markah sahaja. Tapi kalau you stuck, you don't know the formula, you will not get the mark lah. So you just write tekan calculator, you dapat the unit. Okay, but make sure, so for this question, 2 marks if you write the answer with unit. Dengan unit, you dapat 2 marks. So 1 mark writing the formula, yeah, and second mark answer with unit. Yeah, remember you must write the formula. Formula ada markah. So that's easy. Okay, any question about this? Okay, so dekat sini yang susahnya I think this question will be difficult for some of the students because of ni. You may not remember how to relate period to the frequency. Okay, dekat sini you are expected to know, kat sini given the frequency, you are expected to know that period is related to frequency in this way. Ataupun frequency equals to 1 period. Samalah ni. Alright, so daripada situ. Itu sahaja saya rasa susah. Yang lain semua benda biasa. You know diode, you know this formula, you tahu. Alright, yang lain okay, conventional current and the formula P equals to VI. Okay, if there is no question, saya move on. Kita ada a few more minutes. Okay, so ini adalah basic magnet. Okay, which is quite easy. Alright, read the question. Figure 7.1 shows a small plotting compass which is aligned with the magnetic field between magnetic poles A and B of a U-shaped magnet. State the polarity of the poles. Okay, now pole A is, okay, you tengok kita ada magnet ya, kita ada magnet. Kita ada magnet. Okay, so ini ada magnet. We have magnets here and then we have compass here. Okay, dah baca dah?
Dah.
Okay, so that's easy. Alright, so you kena tahu ya, hari tu saya dah bagi Cikgu Zaimah. Alright, ni the magnet itself, magnet sendiri dia sentiasa menunjukkan north Ini south. Okay. Kalau magnet itself, okay, kalau kita ada magnet sahaja di mana-mana, dia menjauhi magnet pula, sorry if this is compass. Kalau kita ada compass saja, and compass tu kita letak anywhere, dia akan sentiasa menunjukkan north. Okay. Tetapi sekarang the compass is placed in between the magnets. Macam ni. So, adakah it will point to the north as well? Jadi kat sini kita tengok this is north, this is south dia. So, that's the position. Jadi, A tu is the, okay, kat sini adalah south. Jadi sini dia connect, dia macam ada attraction lah. South ni attracted to north. Yes. So here is the north. So this is north. North is attracted to south. Okay. So A is north. And B is south. So student jangan salah. Selalunya student dia akan tersilap bila dia ingat sini north, so sini pun north. That is wrong. Jadi dia akan pointing, dia macam attract. North ni dia point sini because it is attracted to south here. South ni dia attracted to north here. Okay, so that's easy. 1 mark only, you see. For both of these, you got it right. You only get 1 mark. Okay, figure 7.2 shows a wire placed between two poles, carrying a current in the direction of the arrow. On figure 7.2, draw an arrow to show the direction of the force on the wire due to the magnetic field. Okay, so ini dalam topik apa? Ini dalam topik masih lagi elektronik. Dia sebenarnya chapter elektrik ni very large topic. Okay. And kita ada tadi bahasa kita dapat Q equals to IT, Q equals to NE about charge, and then about voltage, and then circuit, series and parallel. Okay, dalam elektrik juga, okay, ada EMF sikit tadi. Kita ada topik electromagnet. Okay, another large topic under chapter electric. So electromagnet, you learn about magnet and kita about force. So here ni force. Force on the wire due to the magnetic field. Remember? So first of all, kita tahu without the conductor, if there is no conductor here, kita akan sentiasa tahu north, dia punya direction of magnetic field from north to south, north to south, north to south. Betul? Okay. Now, sekarang ni, the conductor, this is wire. So, the wire is carrying a current. Wire carry a current. Maksudnya sekarang, in this conductor, current is flowing. Now, remember when we have a conductor, saya selalu cerita tentang ni, when we have a conductor, sorry. When we have a conductor, okay, so this is a conductor. So when you connect the conductor to power supply, okay, current flows. What happened to the conductor? Am I online? Conductor tu dia akan magnetize.
Magnetize.
So bila dia ada magnetize, dia ada magnetic field around it. Okay, betul tak arah saya tu? How do you know the direction of magnetic field? You use right hand grip rule. So kita dapat dia clockwise. Is that correct? Okay. So tak apa. Ini satu. This is the basic thing that you have to know. Okay, now ini sebenarnya dah ada dalam kepala lah. Okay, so you tak payah cerita pun dalam soalan, tapi you dah tahu. So now you know we have a conductor. The conductor ada current. So that means the conductor itself dah jadi magnetized. Dia jadi magnet dia sendiri. So when there is magnet, macam ada two magnets interact. Satu dekat sini, magnetic field dia this way. Kan? And then kita ada juga magnetic field north to south. So we know now we have two magnetic fields interact. This one magnetic field due to the wire. This one magnetic field due to the magnets. So they interact. When they interact, that creates force. So what am I talking ni? Apa yang saya cerita ni boleh jadi your explanation to the answers. Kalau soalan ask you to explain. Kalau soalan tak explain, dia minta you jawabkan dia punya apa? Application. So that's how. So on figure 7.2, draw an arrow. So itu hanyalah konsep sahajalah. So soalan just want you to write the arrow. So you can use Fleming's
Left hand rule.
left hand rule. Saya ni. Ya, left hand rule. Jadi you use your Fleming's left hand rule, keluarkanlah tangan masing-masing tu. So current, your middle finger pointing to the direction of current. And then your index finger, tahu index finger? Index finger tu finger yang number 2. Finger yang number 2 pointing to the south, and then your thumb is now pointing up or down?
Upward.
Yep. Okay, everybody should get it upward. So you draw. Dia kata soalan nak draw an arrow. So arrow you mesti straight, vertical. Okay, tu dapat markah straight. And then you kena tunjuk lah dia nak arrow kan. So it upwards. So that's the answer. 2 marks for that. Okay, sebab dia kind of difficult for some students. Okay, kita move on. Okay, masih nampak screen saya ada soalan?
What's the difference between Fleming's left hand dengan right hand rule?
Okay, Fleming's left hand rule is used when you know the direction of current. Okay, ada current kat sini, ada. Current tu this way. But right hand rule, Fleming's right, kalau eja right macam ni kan. Right hand rule, it's for induce current. I for induce, I for right. Itulah. Jadi kalau induce current, that means kalau kita, sebab ada orang tanya saya pergi sekejap. Kalau kita ada, let's say, this one bukan power supply. This is galvanometer. And then saya ada conductor. Okay, conductor ni. Ni wire lah. Ni wire. Ni conductor. Okay, ada current flowing tak? Tak ada. No power supply. Galvanometer is just to detect. Dia adalah instrument to detect presence of current. And galvanometer, okay, usually kita use galvanometer. Why? Sebab galvanometer the current that produce is very, very small current. Kalau usually kita guna ammeter. Ammeter kalau current tu besar lah. 1 ampere, 2 amperes, 3 amperes. Tapi kalau the current is very very small, we just use galvanometers. Okay, next. Now what happened? Okay, now there is no power supply, tak ada battery, tak ada apa, no current. It's just a conductor. Jadi what happen if you turun naikkan the conductor pada um, magnet north south. Okay, boleh imagine tak? So sekarang ni apa yang saya buat? Okay, now imagine the conductor ni saya gerakkan dia macam ni. Nampak tak? Saya gerakkan dia. Jadi sekarang without this, we just have magnets. Kan? Kita ada magnet tu sahaja. Sekarang ni, okay, and then you know that magnets kita ada apa? Kita ada sentiasa ada magnetic field. Dia ada poles and then dia ada magnetic field. Betul tak?
Betul.
Alright, so now kalau without disturbance, maksudnya without anything cutting the magnetic lines ni. So now nothing is cutting it. Dia macam tu sahaja, betul? No change, no cutting. Jadi sekarang dia macam ada cutting bila kita oops, sorry. Okay, bila kita bawa ni, kita seolah-olah the conductor tu potong the magnetic field lines. Nampak tak? Okay, so bila ada cutting of magnetic field lines tu, dekat situlah kita ada process of induced current. Jadi dekat sini, the direction of motion tadi you yang buat. The direction of motion, you katalah you push it down. The force, you force the conductor downward. You push it down. Jadi you use your Fleming ataupun you use your right hand rule to determine the direction of current in the conductor. So soalan boleh tanya, what is the direction of the current in the conductor? What is the direction of induced current in the conductor when you push the conductor downward? So barulah you gunakan right hand grip rule. Jadi your thumb will be pointing down. Thumb pointing downward. Sebab thumb tu force kan. And then current you tak tahu arah mana, tapi you punya index finger pointing to south. So current kita on the conductor right now, semua orang tengah buat ke? Kalau you all tengah buat sekarang, conductor a direction of current to the right of my screen ataupun your screen ataupun to the left of your screen. So you dapat this way. Dapat tak semua orang?
Dapat right.
Terasi? Betul?
Dapat this.
Okay, so that's the difference between Fleming's right hand rule dengan Fleming's left hand rule. Okay, right? Next question. Figure 7.3 shows a beta particle moving in the direction of the arrow between the same two poles. On figure 7.3, draw an arrow to show the direction of the force on the beta particle due to the magnetic field. Okay, sekarang kita ada beta particle. Now, what do you know about a beta particle? Di awal, yes, it's negatively charged. Okay, yang ni alpha. Alpha particles always positive. Tapi soalan ni, dia mention beta and you have to know beta is negative. Okay, so beta is negatively charged. Jadi, you have to understand that beta is a particle and it can be deflected. Can be deflected by magnetic field. and electric field. But now we are talking about magnetic field lah. So kita ada magnet sini. Alright. So what's the direction? So you can use Fleming's right hand rule ataupun Fleming's left hand rule, students. Kita ada dua kan? Kita ada Fleming's left hand rule ataupun Fleming's right hand rule. Ni for induce right for induce. Jadi kat sini nak guna Fleming's left or Fleming's right. Jadi saya cakap tadi, you use Fleming's left when you know direction of current. When you know the direction of current, you use Fleming left hand rule. Okay, kita guna Fleming's right hand rule when you don't know current ataupun current not given ataupun induced current. Okay, so this one, do you know the direction of current? Yes.
Itu
Yes
current.
or no? Yeah, so you need to know current. Okay, ingat tak kita ada buat soalan ni tadi? Okay, direction of electrons. So electrons tu dia discharge, is a charge. Tapi the current, the electrons tu yang seolah-olah produce the current because of the charge moving, electrons. So this is an electron. Katalah saya buat macam ni. Okay, ada charge electron. So this electron, it's an electron, and it is negatively charged. Because of this electron moving, electron ni bergerak, and that's why kita ada current. So the current is there because of presence of electrons. So back to the question.
Cikgu, beta particles ni.
Yes, beta particles is an electron. Okay, so you need to know beta particles punya ciri-ciri. Soalan ni dia expect you to know. So first you know it's the characteristic is negative, and that is actually an electron. Jadi dekat sini direction this way. Tapi electron ni dia opposite to the current, betul tak?
Betul.
So if the current is to the right of our screens sekarang ni, jadi you must use your left hand rule ataupun right hand rule.
Left.
Left hand rule. Tapi sekarang direction of your index finger, keluarkan index finger you all. Index finger you all pointing to
South.
Okay, south. Okay, your middle finger to the right ataupun to the left?
Left.
Yes, to the left of the screen. So left screen sinilah, left hand side, ini right hand side. Jadi your middle finger mesti ke arah left. Sebab sekarang kita ada beta particle, and beta particle is electron. Electron dia opposite to the direction of current. So you point to the left. Okay. Jadi sekarang ni, where is your thumb pointing towards to? Everybody,
Upward.
your thumb upward or downward?
Downward.
Downward. Jadi jawapan for this question, okay, draw an arrow to show direction of force. Everybody tadi finger you all macam ni, betul? Your thumb. Okay, this is your thumb. Yang ni lepas tu you ada jari ni, so ada jari ke sana satu, jadi ke sana satu. So this is your thumb. Betul tak? Semua orang dapat macam ni. Okay,
Betul.
thumb ni show the force, yang ni show to the south, yang ni show the current. Okay. Nampak negatif. Right? So that's how. So electronic ni opposite. Elektron ke kanan, current ke kiri. Jadi ini kena tahu. Okay, so we are done. Dapat 5 markah for this question. Easy or difficult? Depends. Ya. Yeah? So yang mula-mula ni senang sahaja. Lepas tu yang ni pun tak berapa susah. Okay, yang ni kena tahu the basic concept. Okay, soalan kita pergi terbalik tadi. Kita start daripada soalan 10. So sekarang kita masuk soalan number 6. Okay, this is very easy question. This is kita dah move on to the new topic. Okay. So tadi kita dah habis study electric new topic. And then kita dah habis kita tengok soalan awal tadi, we did radioactivity kan? Ataupun nuclear physics tadi. Dan so now kita masuk topik with a light. Light. Okay, light pun besar lah. It's a quite large topic. Okay, ada banyak yang kita belajar tentang reflection, refraction, diffraction. So for this one is refraction. Okay, focus on refraction. Okay, so kat sini dia guna the word term thin glass lens. Thin glass. So this is thin glass. Okay, so you kena tahulah. Thin glass tu is usually lens. Is a lens. So lens, light pass through the lens. Bila light pass through the lens, so maksudnya kita bukan ada reflection lah. Kita ada fenomena refraction of light. Tapi what is refraction? Refraction of light, okay, it's a bending of light. Okay, light is bent. Kenapa light is bent? Sebab ada, kenapa? Kalau soalan tanya why ada, kenapa refraction happens? Ataupun soalan tanya what is refraction? Refraction is a phenomena of bending of light ray. Kenapa light bending? So that is another question. Light bending because of?
To another.
Yes.
Different medium.
Yes, different medium. So sebenarnya different medium tu disebabkan oleh different velocities. Okay, different velocities of the ray. Okay. Sebab sekarang ray ni dekat in the air. So dia ada speed yang laju. Now the ray is in the glass ke ataupun perspex ke. So ni different medium. So the velocity of the ray diagram akan slower. Macam tu lah So that's the basic concept. Okay. Now, determine the focal length of the lens. See, what's the focal length? Soalan ni susah ke senang? This is very easy. Ya. Soalan ni dia bukan suruh you write down, dia bukan suruh you label ataupun mark. Dia nak determine. What is the meaning of determine? Dalam hidup ni when you determine means you have one decision lah, betul? I am determined to do this. I am determined to attend class during school break contohlah. So for this question, determine focal length, what is the question once actually? Class, students?
Kita pilih.
Kita pilih apa? Ada pilihan ke given to you and you have to choose? Macam tak ada kan? So you kena faham ya, the word determine here means the question wants an exact value for the length. Okay. So that's so in order to answer IGCSE question, you have to understand the question first. So dekat sini kadang-kadang kan student dia buatlah label, determine focal length. Oh, soalan nak ni kot. Maybe this one, maybe this one. Okay. Jadi kat sini, okay. Sebelum tu kan saya nak cepat-cepat ya, kita ada 4 minutes left. So kita ada lens dekat sini. Okay. So katalah kita ada, sekejap So kita ada principal lens. Okay. So bila kita nak draw ray line, so kita ada rules dia, prinsip dia kan. Principle of ray tu. So first, light to travel, katalah this is the object. Okay, sama ada you know, right parallel, parallel and then to focal point. So kalau you know the focal point, you will draw like this. Okay, that's the first one. Okay, and then second one, to optical center. Mana optical center class? Students? Sini kan?
Yes, teacher.
Betul. So you will draw line straight here. Now, actually, dia ada yang ketiga you kena tahu. Ada satu lagi lah. Okay, satu lagi, bila you ada, okay, katalah kat sini ada focal point juga. You buat line tu ke focal point, sampai to the lens, dia terbalik dengan ni. Okay, so yang ni, F dulu, lepas F parallel. Okay, so you akan pergi mana? Ni. So ni ada tiga cara. So kadang-kadang soalan minta yang cara ni. Ini dan ini. Kadang-kadang dia tak bagi yang ni, dia bagi from here to here. Okay? Now, back to this question, determine the focal length. Jadi kat sini, dia dah draw dah soal line. So what rule dia buat? Rule number 1 and 2 ataupun 2 and 3. Yang ada pada gambar ni, rule prinsip yang mana? 1, 2, 3, 1, 2 or 2, 3, 2? Ni lah. Ni. 1, 2, 3. So this one dia buat yang mana? 1 and 2. 1 and 2. So 1 first parallel to focal point. Jadi you tahulah focal point. Yang ini dia bending ni towards the focal point. Jadi kat sini kita tahu, you should know. The word is should. You should know where is the focal point. So the focal point is this one here. Kenapa you tahu? Sebab you tahu this rule. You tahu the line must pass through focal point. So that's the focal point. Jadi soalan bukan ask you, soalan tak tanya mark the focal point. Tak. In fact kat sini dia tak guna point, dia kata length. Jadi how are you going to answer this question? You take your ruler, ambil ruler, letak 0 dekat sini. Sorry. 0 must be where? Kat mana 0 you? You start measuring from the optical center. Okay. So your 0 is here. Okay, so take the ruler. Take the ruler, bring it here. So 0, you measure lah. What's the length? Okay. So kat sini saya zoom in, zoom out lah. Jadi everybody kalau you ambil you punya pembaris letak depan screen, you will get different answers. Tapi kalau you elok-elok dekat kertas, you will get somewhere around 2 cm ataupun 1.9 cm, something like that lah. Kat sini kan markah ada. Kalau awak tahu value pun, awak dah tahu F dekat situ, awak tahu value but you don't write cm, that's wrong. Yeah. So you mesti ada the unit. You must include the unit so that kita tahulah you are referring to 1.9 cm. Sebab we don't know, maybe you use millimeters. Kalau you guna millimeters, you letak 19 je, kita tak tahulah apa 19 apa. So you letaklah 19 millimeters. Okay, unit is very important. Circle 3 items in the list which describe the nature of the image formed. So that's easy ya. Soalan ni macam soalan free. How can you know the answer? Sama ada you hafal ataupun you tengok sahaja. Where is the image? So you tengok arrow, agak-agaknya you tengok arrow ni, you boleh tahu tak mana satu image, mana satu objek.
Image
Okay.
yang belah kanan.
Yes. Okay, so you look at the arrow. Arrow from object to the image. So here is the object, here is the image. So the answer is in the diagram. So what characteristic do you see of the image ni, object tu? It's an enlarged. Is it upright? No. Is it apa lagi? Inverted. And okay, is it whether it's real or virtual?
Virtual.
How do you, macam mana nak bezakan whether it's virtual or real? Okay, listen carefully. So for lens, okay, listen ya. For lens, if the object ataupun if the image at the same side of the object, it is virtual. Okay, kalau image di sini juga, so this one, kalau lah kita kata, oh this is the image, this is object, so we see both of them are at the same side. So kita kata image ni adalah virtual. Tetapi sekarang the image is on the opposite side kan. So the object here, image di sini. When they are at the opposite side, kita ada real image. Okay, so the answer is yes. So you have to circle the three of that tu, barulah dapat full mark. Okay. Next, final answer, final question. State one feature of virtual image. Okay, dia bukan nak tanya awak fahamkan soalan. Nampak kat sini tahun ni punya soalan dia banyak perangkap-perangkap. Dia macam dah biasa soalan tu tapi dia bukan tanya soalan yang biasa. Macam tadilah, dia nak you determine. Student mesti tak ambil pembaris. Mesti student buat macam-macam. Okay, so you have to understand the word determine. Length. Next, dia kata feature. Dia use the word feature. State one feature, one ciri-ciri. Feature tu macam ciri-ciri yang you nampak as a virtual image. Dia tak tanya, what is a virtual image? Kalau soalan tanya, what is the meaning of virtual image? Your answer would be, so virtual image is the image that cannot be caught on screen. That's the meaning of virtual image. Tetapi soalan ni dia nak feature of virtual image. Jadi you jawapan ada pada gambar you all. Yeah. So what do you
Same
see?
side with objective.
Okay, ada lagi tak? Dia nak yang macam mana? Okay, so it can be ada. So sebenarnya ciri-ciri ni pun boleh jadilah jawapan dia, you boleh cakap lah. Cannot image, cannot be, sorry tak ada, sorry. Jawapan tak ada pada soal gambar. Sebab gambar ni real kan? Sorry saya silap. So soalan ni nak terbalik, dia nak virtual pula. So jawapan dia lah image cannot be projected, cannot be caught on screen. Jadi boleh lah yang ni sebagai jawapan. Ataupun ada tak jawapan lain? What is the meaning of virtual image? Not an intersection of rays. Yang ni maksudnya faham tak ni? Ingat tak kalau lens ni macam ni, and then image ni focal point, focal point kat sini, objek di sini. Lepas tu kita nak lukis image. Ingat tak cara lukis image? Parallel. Lepas tu ke focal point kan? Right. Lepas tu ke optical center. Jadi kat sini dia takkan bertemu. Jadi kita buat dia ke belakang. Dia buat ke belakang. Jadi apa yang dia cakap ni? Not an intersection of ray. Maksudnya yang dua ni dia tak intersect. Yang intersect adalah line yang putus-putus yang kita buat ni. Yang extrapolation ni. Extrapolation ni yang intersect. Bukan the rays. Rays yang ni. Itu maksud yang ni Ataupun kita kata light rays do not pass through image. Light rays do not meet ni. Light rays do not meet. Okay. Alright. So I think that's all for today. Jadi kita recall balik apa yang kita dah belajar hari ini. Jadi baru sekejap tadi kita tengok light. Light ni ada besar Dia ada reflection, refraction, and then refraction also is such a big topic. Okay. Kita dalam refraction ni kita belajar tentang simple refraction and then Snell's law, refractive index. Kita tak tengok lagi contoh soalan tapi kita tahulah ada refractive index. Okay, and then refraction kita ada topik critical angle, and then kita ada total internal reflection, and then application of lens, thin lens. So yang kita tengok tadi only this part here. Okay, so untuk thin lens pun you need to know the drawing. Yeah. Okay, next dalam tajuk light juga kita ada diffraction. Okay, then kita ada dispersion of light ray. Okay, so light is such a very, it's quite a large topic lah. Okay. And then kita tengok tadi banyak tentang electric. Electric tadi kita tengok tentang magnet, simple magnet. And then kita tengok tentang electromagnet. And then biasalah tadi kita tahu tentang Ohm's law. Ohm's law V equals to IR. And then ada power VI. And then kita ada tentang circuit. Circuit ada parallel and series circuit. Okay, tapi sebelum tu lagi, sebelum Ohm's law, you kena tahu tentang charge. What's the symbol of charge? Siapa yang join tadi? Awal-awal tadi? Q.
Okay.
So what's the formula for charge? Q equals to NE. Q equals to IT. So nampak this formula dah kena tahu by heart. Tahu dah bila nak guna. Okay, and then kita tak study sangat EMF, tapi adalah sikit soalan tadi sebut tentang EMF. So you see banyak topik-topik yang besar dalam tajuk elektrik. And another one, apa yang kita tak mention lagi? Electronic. So this electronic is another large topic. Electronic itself. You kena tahu the components and the gate, logic gate. Logic gate ada 3 sahaja komponen utama yang you kena tahu, and then you kena combine which are and,
Not,
and this one, or ni not. Jadi tapi 3 ni kita boleh combine lah. Ni kita combine kat sini, kita boleh combine kat sini, macam ni, and so on and so forth. Okay, and tadi kita ada tengok sikit tajuk nuclear physics. Alright, so malam esok ke, saya tak sure, malam, ada satu malam, kita akan sambung lagi, kita tengok satu lagi contoh soalan dan kita buat paper 6, ya. On your part, sebabkan dah nak sangat IGCSE, lagi berapa minggu ya, you all? IGCSE, okay, less than 1 month. Jadi you nak tak nak kena buat paper 1 sebab tu ni lain lah kalau contoh untuk paper physics kita ada paper 2, paper 4 and paper 6.